This presentation on 3D printing is brought to you by Group 11. We will discuss 3D printing's history, current users and uses, the potential positive and negative impacts resulting from this technology, as well as where the future will take us.
In this section, we'll go over a brief explanation of the 3D printing process, its precursors, and its more recent history. It's interesting to see how they're also connected. 3D printing is the process of using additive material to form solid 3D objects of virtually any shape from a digital model. This is done using specially formulated additives, plastics or metal powders for example, that are laid down in successive layers to create shapes. Often this comes in the form of a filament. This is what's different about 3D printing as a way of making products or prototypes. They're called additives because the models are made by adding material rather than subtracting material like clay, the typical way in which models are made. So a modern 3D printer reads a design from a file, like a CAD file, then lays down successive layers of liquid, powder, or some other meltable or bindable material. These layers correspond to the cross-sections from the CAD model and allow users to create any shape or configuration. The idea of 3D printing had actually been around a long time. Something called photosculpture predicted the process. Developed in 1860 by Francois Willem, an object was placed in a circular room, then simultaneously photographed by 24 cameras placed equally around the circumference of the room. From that information, an artisan carved a 1/24th portion of the figure. That level of planned information is managed information. These pieces were later assembled. So with a little subtractive modeling, a little additive modeling, one very new process making use of managed information was developed. Then, as early as 1892, J.E. Blanther, in his patent Manufacture of Contour Relief Maps, suggested a layering method to modeling. This process utilized map information to impress topographical lines onto wax plates, then stacked and smoothed the sections together to create the model. It took some time, but skipped to 1951 when the additive process via managed information showed up again with O.J. Munz's photoglyph recording process, which exposed a transparent photo emulsion in a layer-wise fashion, with each layer coming from a cross-section of a scanned object. This process came even closer to today's 3D printing in that a machine then lowered a piston in a cylinder and added appropriate amounts of photo emulsion and fixing agent, creating the layers that in turn created the object. In 1971, P.A. Surratt wrote a paper describing a process that utilizes meltable material as its additive. This is in contrast to layers cut via obtained information, then stacked to create the model. Then in 1974, P.L. Di Matteo suggested in his own patent a stacking process that could be used for created surfaces that were difficult to mold using standard machining. This helped bring about the process as a less labor and cost-intensive way to model prototypes and other difficult or one-off products. 1979 was the year that the selective laser sintering process was patented. The process uses lasers to sinter powdered material together and bind it to create a solid structure and is key to contemporary 3D printing. Which brings us to Hideo Kodama. His process was the functional photopolymer rapid prototyping system, and it created the first printed solid model. In layman's terms, Kodama's process brings together a number of these technologies. His machine combined these concepts and processes to create a system that fabricated an object by building up a part in the layers from a liquid, but used computer data and an XY plotter to do it. You know, kind of like a printer. The 90s saw the sophistication of 3D printing machinery by the company 3D Systems. This was the first stereolithographic machine that used a UV laser solidifying photopolymer. This means that an ultraviolet laser would effectively draw each layer of the object onto the surface of a vat of resin, then cure the layer and bind it to the last. The late 90s and the aughts brought artificial organs using 3D printing technology. While this sophisticated use of information and technology together is a sign of 3D printing's potential, the technology's recent past also shows us the practical, everyday usage that brings the technology to both manufacturing and the hobbyist. The key takeaway from all this is that so long as new technology has been created, we've found ways to manage information in a way that takes advantage of these tools.
3D printing technology is used by various groups, including, but not limited to, academic institutions, science and research centers, manufacturing companies, both large and small, as well as by individual consumers. 3D printing also has an array of uses, some of which are listed here. These include concept modeling, rapid prototyping, end-use products, architecture, crafts, medical, movies and music, fashion design, and even food. As you can see, 3D printers are used all over the world. Average demand is expected to increase 20% year over year between 2012 and 2017. As of 2012, North America had the highest demand for 3D printers. By 2017, we are expected to account for 42% of global sales. The most rapid growth is expected to be seen in production and consumer use. The personal 3D printing market is growing rapidly, with 86% of current users having purchased their first 3D printer since 2011. This rapid growth is expected to continue, with as many new users looking to buy 3D printers in the next 12 months as those who have already purchased them. 3D printing can be used for a variety of things. Unfortunately, different printers have different capabilities. A recent study shows that current users of 3D printing have on average 1.7 printers, with 10% of users having 4 or more. These printers aren't just sitting around in someone's basement either. A study also shows that 83% of users said they use their printer several times per week or more. So what are individual consumers and hobbyists making with 3D printers? Well, anything their creative minds can think of. And for those who aren't as creative as others, there's a new beta website available based on the concept of Pinterest. It's called Pinshape. This site allows users to search through thousands of design templates and either order customized 3D items directly from the site or stream the files to their home printer. Medical uses of 3D printing are endless. In the past few years, there has been success in creating and even implanting various prosthetics as well as creating functional organs. In 2000, researchers engineered a miniature working kidney able to filter blood. 2008 was when the first person walked using a 3D printed prosthetic leg. In 2012, a 3D printed titanium jaw was implanted in a cancer patient. And just this past year, the same was done with a prosthetic pelvis. In the movies industry, 3D technology is used to create more real-looking effects. You can see from the characters provided as examples, 3D printing has helped us come a long way in the process compared to movies we may have seen 10 to 20 years ago. Each of these characters is fully or partially 3D printed. 3D technology also allows you to print instruments with your own creative flair. Here we have a 3D printed whistle, guitar, drum set, and even a flute. Not only do they have a cool design, they are also fully functional instruments. Within the fashion and design category, we have clothing, shoes, accessories, and even jewelry, all of which can be 3D printed in various designs, colors, and sizes unique to the individual. Jewelry company American Pearl has invested in 3D technology, allowing customers to design and print engagement rings, such as the one pictured here. While 3D printing still has a long way to go in the food industry, individuals can now print items such as candy, chocolates, and even pasta within their own homes. There's also talk that Barilla, the Italian pasta manufacturer, has plans to put 3D printers in restaurants to allow consumers to design their own pasta for meals. Diners can design their pasta at home and bring in the template to the restaurant to be printed, allowing for a unique, customized experience, such as eating pasta in the shape of a rose on your anniversary.
So what are the positive aspects of 3D printing? With our society's constant desire to find new renewable energy sources to reduce the world's carbon footprint, it's easy to overlook the significance of everyday use products and items. Think about a modern-day commercial manufacturing operation. It begins with the movement of raw materials, large complex factory lines, and then finished goods are packaged, stored, and shipped to the final consumer. But imagine if you could easily design and print the same product quickly and economically from your own home. Well, with additive manufacturing or 3D printing, this is now possible. On the business side, 3D printing will make mass production of similar goods affordable and quick, saving manufacturers time, labor, and distribution costs. Even if the per unit production cost is higher, it is more than offset by the elimination of shipping and the use of buffer inventories. 3D printing is the ultimate form of just-in-time manufacturing, where a firm can produce a part quickly to the exact specifications needed without producing in large quantities. Rapid prototyping will make testing easier for manufacturers, allowing for quick production of full-scale models, enabling faster new product development. Even NASA has plans to use 3D printing to produce parts, tools, and other gadgets for use by their astronauts at the International Space Station. On the economic side, the U.S. and many other countries will return to nearshoring as production costs will be more economical, making the need to outsource labor unnecessary. The cost of entry into many industries and local competition are also likely to see major shifts in the near future because of 3D printing. On the personal use side, manufacturers will become more consumer-based and responsive to customer needs. Consumers will have greater input into the final product and to meet their design specifications. Consumers will be able to shop for designs online, purchase a CAD file, and print the needed part online without running to the store. There will also be medical benefits. Research is already using this technology to print new skin and apply directly to burn victims. Computers can scan the wound, create a 3D image to match the size of the wound, and apply directly to the skin. Other advances will include prosthetics for amputees, including legs, arms, and ears. On the environmental side, with manufacturing sites located closer to the final destination, product distribution and transportation costs throughout the world will be significantly reduced. The bottom line is we can reduce energy and emissions such as CO2 by making commonly used parts from the home. Manufacturers are researching attached recycling machines which can take a scrap or unused items and recycle them back into raw material for future use, significantly cutting back on the amount of scrap used. Even environmental concerns such as wasted ink during the process are likely to be addressed as the technology continues to improve. Though 3D printing still has a long ways to go in terms of pricing, quality, and efficiencies, the benefits are far too great to ignore.
For every positive impact from 3D printing, there are negatives. The negative impacts are about adjusting, controlling, and adapting to this new technology. Such negative impacts are the learning curve for both business and society, the impact on the environment and the global economy, and the overall impact that this technology will have as it grows. No matter what industry, location, or time frame, learning curves can be expensive, harmful, and have a greater negative impact than necessary. As John Smart points out in his fourth law of technology, first generation of new technology is almost always more dehumanizing than it is beneficial, and 3D printing is unlikely to be an exception. 3D printing increases the ability to commit fraud and identity theft. Fake bank cards have deceived ATM machines and allowed thieves to steal money. False documents such as birth certificates, event tickets, and IDs can create chaos. This chaos will increase the cost of doing business and in turn be transferred to the end consumer. 3D printing gives the wrong people the right tools. Society as a whole has always been impacted by addiction, self-image issues, and security issues. 3D printing enhances all three of these factors and can do more harm than good. For example, altered body grafts are a positive when used right. However, it can be used to increase the challenges to today's youth as unnecessary plastic surgery becomes more prevalent and easier to attain in society. The impact on the environment can be felt by 3D inkjets that waste 40 to 45% of ink, printers that use excessive amounts of electricity, and increased waste and trash due to extinction of modern art due to new imagery will all affect the environment. Multiple studies have shown that particles released by 3D printers are linked to adverse health effects such as cardio and respiratory issues, stroke and asthma symptoms, as well as air pollution. The global impact on the economy, as mentioned before, does have its positives in order accuracy in manufacturing due to 3D printing. However, the overall cost as a whole is a negative. The gap between developing nations and the rest of the world will spread further due to the cost of 3D printing, as well as the cost of education due to product costs will increase. The ability for industry as a whole to keep up with increased expectations can put a strain on markets. The lack of regulations and standards within the industry also present challenges. For example, guns have been produced with precise accuracy due to 3D printing. As much benefit and advancement as 3D printing presents, it also opens up a long way to fall.
Some speculate that natural selection of great designs will occur in the age of digital printing, that 3D printing is the great equalizer between big business and the little guy working out of his garage. But beware, there are limits to natural selection, as high-revenue industries will make bigger investments in larger, more technically capable printers. However, volume for a certain type of product will become less relevant. Capital investments in printer capability can be recovered through varying part production, meaning a diversified product offering doesn't have to cost a fortune. Early adoption industries. High-end, high-value industries like aerospace, automotive, and medical are likely to be big spenders. By 2050, engineers at Airbus hope to print the entire aircraft from the ground up. In traditional manufacturing, titanium wears machine tools heavily as it hardens when cut. These problems are eliminated in a 3D print environment. 3D printed aircraft components are 65% lighter, but as strong as traditional machine parts, representing huge savings and reduced carbon emissions. For every 1 kilogram reduced in weight, airlines save around $35,000 in fuel costs over an aircraft's life. The Mars rover contains around 70 3D printed custom parts. Scientists are also exploring the use of 3D printers in the International Space Station to make spare parts on the spot. What once was science fiction has now become reality. 3D printed kidneys, living skin grafts, advanced prosthesis, and dental implants. The high-end potential for 3D printing in the medical field could be earth-shattering. Although the challenges faced by researchers in the bioprinting field are enormous, imagine the potential payoff if we could successfully manufacture, say, a kidney or a heart valve on demand. It would truly be one of the most significant breakthroughs in the history of medicine. There is a lot of work to do. Printing tissue in the shape of an organ is one thing, but printing a living organ that can withstand the stresses of daily life is another. This is a must-watch future industry. Major car manufacturers such as GM, Jaguar, Land Rover, and Audi have been 3D printing auto parts for a number of years. Stratasys, a Minneapolis-based printer manufacturer, is even trying to print a car, or at least the body of one, for Core Ecologic, a company in Winnipeg who's developing an electric hybrid vehicle called Irby. Military machines are produced in relatively low volumes, which takes a lot of time. Many of the parts of these machines are required to be replaced constantly, so 3D printing will help to produce these parts instantly and efficiently, even in remote locations. Future industries. Bioprinting food. Like bioprinting, this is another arena where the challenges are high, but the potential payoffs are even higher. Current food printers are more for appearances, printing simple things like frosting or cookie dough. There is a great potential possibility that we could one day artificially synthesize products that are either expensive to produce or rare. Meat, for example, is a costly product on a global scale. It takes a massive amount of natural resources to put beef on our tables. If someone could figure out how to produce a replacement for beef at a fraction of the cost, it would be a real achievement. The other real promise is the potential for healthier food products, customized based on the individual nutritional needs of a consumer. Again, this is all hypothetical, but the potential is there. Open source printing. Current 3D printers in the consumer market are limited. They're limited by both the print resolution, as in how precisely they can print, and by material. Consumer printers do well with plastics, but anything beyond that is still undeveloped territory. These limitations mean that for the time being, consumer printers are an interesting novelty, but don't offer enough solid utility and convenience for widespread market adoption. However, this will change over time, and these technical challenges will be overcome when there's money and convenience on the line. Electronic materials and gadgets printing will be commonly used for designing and printing electronics with the best possible shapes and styling properties. 3D printing is perfect for these complex geometric features. Jewelry printing will allow anyone to instantly produce and design whatever they want and wear according to their need, completely abandoning the traditional process of manufacturing jewelry. Toys manufacturing. In the future, children will be able to manufacture toys by downloading 3D design files, modifying and customizing them as they want in their homes. Problems. 3D printing has recently hit the news as a young American was able to create a working firearm by using a 3D printer to build the lower receiver, the only part of a gun which can't be easily purchased. Only a few months later, 3D models of an entirely printable gun appeared on the internet. These homemade firearms are highly dangerous and in many countries illegal. The Danish company Create It Real, however, has found a solution to this issue. Upon opening a 3D file, the smart software scans the model and tries to match its characteristics with the characteristics of a firearm. If certain features align, the software will not allow the user to view and print the model. Critics are skeptical that software can protect us from mass production of weapons by the wrong people, and it will be interesting to see how this issue develops. Patent infringement. Though 3D printing offers the opportunity to make meaningful contributions to our society, there also exists the opportunity for individuals to look to exploit others' hard work and to abuse this technology by trading in counterfeit and pirated goods. Patent infringement will be a significant challenge in the future, and some say it may be a major limiter in openly sharing designs for print in the 3D market space.